rapid increase in population, there is a tremendous increase in the demand of energy resources to meet household needs in Indian villages. Still, about 60% of rural people depend upon traditional sources of energy, that is firewood, cow dung cakes, etc. Keeping in view the difficulties faced especially by rural women in meeting their energy demands, biogas technology can be an appropriate answer. Biogas technology helps us to generate biogas from biomass, that is cow dung, crop residues, etc., which are available in abundance in the rural areas. Biogas is produced by anaerobic digestion. Anaerobic digestion is nothing but decomposition of cattle dung and other organic matters with the help of microorganisms in the absence of oxygen. Anaerobic digestion provides us methane gas for cooking, and in exchange of fresh-fed cow dung slurry in the plant, we get well-digested, valuable manure rich in nitrogen. What is biogas? Biogas is a mixture of methane, carbon dioxide, nitrogen, and some traces of gases like hydrogen sulfide, ammonia, and water vapor. Biogas can be utilized for cooking and lighting, running diesel pump sets, and the outcoming slurry as manure in the fields. On an average, biogas contains about 50 to 60% methane, 30 to 40% of carbon dioxide, and traces of nitrogen, hydrogen sulfide, and ammonia. The digestion of organic matters can be done in two ways: batch digestion or semi-wet process, continuous or wet process. Batch digestion. In the batch digestion process, the organic matters are filled in a suitable container along with some moisture. This container is then sealed to exclude air from it. The gas formation, which starts after 1 week, can be collected in centrally located gas holders and can be used for 30 to 40 days. Continuous process. In the continuous process, a single container serves as the digester. Each day, we add a required amount of fresh feed or slurry, and an equal amount of digested slurry comes out. It provides us gas continuously, and on the same principle, the biogas plants work. Let us understand now what are the different factors that affect biodigestion. pH or hydrogen ion concentration, temperature, total solid content of the feed material, carbon-nitrogen ratio of the input material, retention time or rate of feeding, types of feedstock, stirring or agitation or mixing of the content of the digester, type of initial inoculum, acid accumulation inside the digester. Now let us understand these factors one by one. pH or hydrogen ion concentration. The digester is usually buffer if the pH is maintained between 6.5 and 7.5. In this pH range, the microorganism will be very active and biodigestion will be efficient. Temperature. The required temperature inside the digester for effective growth of microorganisms and biogas production is 20 degrees centigrade to 42 degrees centigrade. total solid content of the feed material. The cow dung is mixed with water, usually in the proportion of 1:1 by weight, to keep the total solid content about 8 to 10%. Carbon-nitrogen ratio of the input material. The optimum carbon-nitrogen ratio is 30:1 for the maximum microbial activity. Retention time or rate of feeding. The period of retention of organic matters inside the digester for complete digestion by the microorganisms is known as retention period. Retention period for some of the feed materials are cow and buffalo dung 50 days, night soil 30 days, pig dung 20 days, poultry dropping 20 days. Type of feedstock. All plant and animal wastes can form the feedstock for a digester. However, woody materials are avoided to keep the process of digestion smooth. Stirring or agitation or mixing. Breaking the scum or the matte formation at the top of the digester is necessary for enhancing gas generation. Types of initial inoculum. The initial inoculum is the biodigested slurry collected from a well-established digester. It helps in providing sufficient number of microorganisms. Acid accumulation inside the digester. Some fresh plant matters added in excess may produce acids as intermediate products. Avoid adding excess fresh plant matters inside the digester. Some of the family size biogas plants are floating gas holder, commonly called KVIC type, with 1 to 10 cubic meter capacity. Fixed dome, commonly called Janta type biogas plant, with 1 to 6 cubic meter capacity. Pragati model with 1 to 8 cubic meter capacity. Modified fixed dome called Deen Bandhu model with 1 to 6 cubic meter capacity. The KVIC plant has a digester made of prefabricated ferro cement. The KVIC plant also has a gas holder made of fiberglass reinforced plastic with a 1 to 6 cubic meter capacity. FLXI biogas plant with 1 to 6 cubic meter capacity, which is portable and made of rubber. Apart from this, the community-sized biogas plants can be useful for a bigger community. Now let us understand the function and construction techniques of KVIC biogas plants. The KVIC or Khadi and Village Industries Commission type biogas plant consists of a mixing tank, an inlet pipe, digester, gas storage, center guide frame, outlet pipe, and an outlet chamber. Before the construction, we select a right place for the installation of biogas plant. Firstly, mark a line on the ground for digging a pit as per the size of the digester. For a 6 cubic meter capacity digester, we dig a pit of 10 feet diameter up to 8 to 10 feet depth. In order to lay a strong foundation, we do ramming of the brick bats with soil. The materials required are bricks, sand, stone chips, cement, and pipe for the construction of a digester, and we fix the center guide frame. An inlet and outlet chamber is constructed. The fabrication of steel gas holder is done separately by a mechanic. Initial feeding with fresh cow dung slurry with some digested slurry is done before fixing the gas holder into the biogas plant. We have here the views of a KVIC biogas plant user. We are using biogas for cooking all items like chapati, dal, vegetable, milk, tea, etc. It is more useful than LPG. There is no danger in using this gas. The outcoming slurry is also used as good manure in the fields. Now let us understand the function and construction techniques of a Deenbandhu type biogas plant. Deenbandhu type biogas plant consists of a mixing tank, an inlet pipe, digester made of bricks, dome, and an outlet chamber. The digester cum dome is covered under the earth for its protection and to maintain temperature. Now for the techniques of its construction. First, we select an appropriate site and mark a line on the ground for digging a pit as per the size of the digester. Materials required for the construction are bricks, sand, stone chips, cement, and pipe. In order to lay a strong foundation, we do ramming of the brick bats of 4 to 5 inches depth. Further, we prepare mortar in the ratio cement 1 part, sand 2 parts, and stone chips 4 parts. Above the rammed foundation of a digester, a 3-inch layer of mortar is applied to stop any type of seepage. The digester is then constructed with bricks and it continues up to the dome. An outlet tank is also constructed along with the digester. In order to keep the radius equal all along the digester cum dome, we use a measuring stick. After a certain height, we put counterweights with hooks in order to give support to the arc-shaped wall for better stabilization. We have the views of an expert about its construction. In the lower part of the dome, we use mortar of sand and cement in 5:1 ratio, which is gradually reduced to 4:1 and even up to 2:1 at the top of the dome. We use full-size bricks in the construction up to half the dome. As we go towards the upper part of the dome construction, gradually we use 3/4, half and even quarter size of the bricks as the circumference of the dome reduces.
उसके बाद ईंट है जो 1/4 कर दी जाती है और गैप कम करने के।
We have a view of the dome from inside. The radius is always kept constant by regular measurement. Thus, the dome is constructed. Here, we can observe the different size of bricks laid at the top in different layers. At the top, a template or shuttering is done and a gas outlet pipe is fixed with concrete. After the completion of the dome construction, we apply slurry of cement in order to fill up the gaps or any hole. Then, a 1-inch concrete layer is applied over the dome. Similarly, a 1-inch layer of concrete is applied to the inner surface of the dome. The full constructed biogas plant is covered under the soil for its protection from the heat and cold. Now, a pipeline connection is given up to the kitchen. The plant is ready for initial feeding. Initial feeding is done through an outlet chamber. Here, we see a local technique of initial feeding with the help of wooden shutters. A bulk amount of cow dung mixed in equal proportion with water is fed from the outlet chamber. Within a week of initial feeding, regular gas production starts. Let us have the opinion of a user of the Deen Bandhu type biogas plant. My name is Gursev Kaur. I belong to village Benra. We have been using a biogas plant for the last 4 to 5 years. It is very useful for us. All our cooking is done on the biogas. Only in December and January, we require to use 1 cylinder of LPG, otherwise we use biogas for the whole year. Chapatis for 10 to 15 people can be prepared within an hour. It is very cheap and useful. It is very safe. There is a chance of a LPG cylinder bursting, but not in this. Now let us have some more views from the experts on biogas plant. Biogas plant has a very simple technology. There is no problem in understanding the repair and maintenance of a biogas plant even for a layman.
ऑपरेशन का ऐसा कोई झंझट नहीं है जिसको कि जो है एक लेमैन भी ना समझ सके.
When we install a biogas plant, we provide a complete guideline and booklet to the beneficiary. We keep a follow-up to check the performance of newly installed biogas plants. The main point is to feed the biogas plant with the cow dung slurry daily in required proportions. There should be no gap in feeding the plant, otherwise the biogas production will be reduced.
बिना नागे के हम उसको प्लांट को देते रहें. इसमें मैं यहाँ आपका जो है प्रश्न के विषय में अपनी राय ये देना चाहूँगा कि कई किसान भाई अपनी तरफ से गोबर डालने में जो है 2-3 दिन का गैप कर देते हैं. वो नहीं करना चाहिए, क्योंकि अगर हम गैप करेंगे तो उससे हमारा जो प्लांट के अंदर जो गोबर ऑलरेडी उसमें भरा हुआ है उसकी शक्ति क्षीण होती है. इसलिए महत्वपूर्ण बात ये ध्यान रखना है कि हम उसको साफ गोबर और पानी प्रतिदिन नियम से डालें, तो कोई कारण नहीं है कि प्लांट हमारा कार्य ना करे.
What are the main points for the selection of a site?
This is a very important point. First of all, we select an appropriate site, especially keeping 2 points in mind. First, it should be near the kitchen. Secondly, it should be near the cattle shed. In addition, the biogas plant should be installed in an open space so that sufficient sunlight falls on it, and it should also be near a water source.
जो स्थान हम बायोगैस प्लांट के लिए चयन कर रहे हैं वो रसोई के नज़दीक से नज़दीक होना चाहिए. और ये भी हमें ध्यान रखना है कि रसोई से नज़दीक होने के साथ साथ उसको जहाँ उसका कैटल शेड है, जहाँ से उसको रॉ मटेरियल उठा करके लेके आना है, वो भी उसके नज़दीक हो. इन 2 बातों का विशेष रूप से ध्यान रखना है. और ये भी ध्यान देना है कि उसके जो स्थान चयन करने में कि जहाँ हम प्लांट का निर्माण करेंगे वो छाया न हो, उसको पर्याप्त धूप मिले और पानी की व्यवस्था भी आसपास में होनी चाहिए, ताकि हम आराम से उसको गोबर और पानी मिला करके उसको डेली फीड कर सकें.
Deenbandhu biogas plant is a low-cost technology. First thing is its cost is 20 to 30% lesser than the Janta model, as well as from other designs. Secondly, its surface area is reduced. When the size is decreased, its cost is also reduced without losing any efficiency. Thirdly, it is a single brick construction, and because there is no joint due to its dome at the top, there is no chances of leakage. Therefore, it is always preferred than the other designs, and these days everybody comes in for Deenbandhu type biogas plants.
Thus we see there is a big potential for biogas plants to meet the future demand of energy in rural areas. It is low cost and environment friendly. Biogas development programs will help in improving the sanitary conditions and quality of life in the villages. It can shape the path for self-sufficient villages in energy needs, which will lead to the sustainable development of society.